Well, hello. It's been a very long time since I put up any video about our robot boat project. I've been terribly busy. Today I'm going to tell you about a collaboration that we're doing with another YouTube channel, Drawing Board 82, which is the channel of a guy called Ollie Epsom. Both of us want a completely waterproof wind direction sensor. Ollie has designed one and I am helping him make it using my little Chinese mini-lathe. So Ollie's design, which he's done in all these modern CAD/CAM things that I know nothing about, involves a wind vane supported by ceramic bearings in a plastic case of some kind, and inside we have a shaft, two open bearings, a magnet, and potted in a completely waterproof case a Hall effect sensor that senses the position of this magnet. These ceramic bearings have no seal because we don't want any friction, and we just hope that although water will get into them, that it won't cause a problem. So here I am in the midst of building this, I suppose it's actually a very simple thing, but it's quite complicated. It's got two bearings in it and various other things. And I'm making it out of Delrin. The problem I'm encountering here is that I want to bore this out to a certain dimension, and I keep losing track of where that end point is because of the more than 1 1/3 revolutions backlash on this screw. So I was thinking, what would be nice is if I could put an indicator on here which measured directly where the cross slide was in relation to the saddle. Unfortunately, it's not so easy to do that. I have got various indicator holders up here, but they're all too big. The smallest one I've got will just clip onto there, but it's not firm, so that's no good. However, I've noticed that there is a hole here, a tapped hole. I have no idea what it's for, but it's an M6 thread. So I was thinking, I happen to have this old holder here, if I could fix that on there, maybe I can get an indicator. Doesn't look very helpful, but maybe I can get an indicator onto that. Well, I've managed to fix this dial gauge on there. Had to file a bit of this bracket here so that it clears the cover of the lead screw, and it's now fouling the lever for engaging the lead screw. Luckily I don't want it to engage the lead screw, so that doesn't matter. I've had to make the dial gauge bear on the top slide, which I didn't want to. I wanted it to bear on the cross slide, but I don't have a choice there because there's just not room. This is one of the reasons for not buying a very small lathe, that there's no room to swing a cat, let alone to attach a cat accurately onto the thing. So because it's bearing on the top slide, the reading is going to change as I move it along a bit. Not much though. So only 0.01 millimeters, so that doesn't matter very much. We'll put up with that. So the depth of the hole I want to bore at the moment is 33 millimeters. So I've adjusted the stick out on this boring bar to be 33.5 millimeters, so that when this edge is 0.5 millimeter from there, we should be at the right depth. How sophisticated can you get? So when I'm at the right diameter, this thing reads 0 and between 7 and 8 on the small scale. So what I'm doing is winding it back towards the centre of the hole. That's it, that's there. Centre of the hole is on 5, right. And I wind it in a bit. And then we come out to 7.5, which is there. And then we rinse and repeat. So then we come out again. Thank God this is only butter and not stainless steel that we're cutting. The question is this 33 millimeters? And of course I can't measure it because there's always something in the light with these things. Can't get that any further out of the way. I suppose I can move it back so long as I don't mess this style up. 32.6, so that could be 33, or nearly right, nearly right. Does it have to be exactly 33? $32.7. That's going to be it. So this bearing is 13 millimeters in diameter. So for a Delrin press fit, we need a hole 12.7 millimeters in diameter. I found this DuPont General Design Principle document which tells you how to calculate a press fit into Delrin with this rather complicated formula here, which simplifies to this if the bearing is a lot more rigid than the Delrin, which is probably not the case in this example, but I nevertheless used this simplified formula, which is probably wrong, but that's what I've done. Well, I'm going to drill this out to 12 millimeters in the hope that then I can use this very small boring bar to bore it out to 12.7. I just want an aluminium spacer to fit in this hole so that I can use it to push the bearing in. And I'm just turning down this piece of aluminium in a very crude way because I can't be bothered to change the change gears back. They're on 1.5 millimeter metric pitch at the moment. So I'm just doing this way. It's not very sensible, but it will achieve what I want. Right, this crudely turned thing will just fit in there and press this bearing in there, I hope. Well, I've made a little insert at the end so that this will fit on here like that. Slightly loose. Trouble is I can't measure the internal diameter that I've bored. I hope it's 12.7. A 12.5 millimeter drill will fit in it somewhat loosely. So we lower that in there and put it in a vise and push and hope for the best. Well, incredibly, I think that worked. It pushed it in there. It seems to be firmly in place. One of the problems with Delrin push fits is that over a period of time the plastic accommodates itself to the increased pressure and therefore the push fit becomes looser. And they say that one way you're supposed to handle that is by grooving the part that you're pushing in so that the plastic kind of gets itself stuck in the grooves. I didn't do that because I just didn't feel like it at the time. Another thing I've just learned is that Delrin accommodates itself to the chuck. So I had this chucked firmly, but not over firmly. And then I went to lunch. And when I came back and started using it, it had gone all loose. So not a good idea to keep the thing chucked for longer than necessary. For the next thing, there's a 16mm diameter hole in here. It's got to be 22mm for the first 13mm in. So that's 13 turns on the handle here, 3 turns on the handle here to bring it out by 3mm each side, which is 6mm in total. What could possibly go wrong? One, 2, 3, 12, 13. So that's 18 divisions, coming out 18 divisions, right? So 10, 15, 16, 17, 18. So this should now be 22. 22.2. Why does everything always overshoot slightly? You noticed that? Without fail, everything slightly overshoots. And you can never get a straight line on anything. And that is 13.4. Alright, well it's supposed to be 13 in 22, but that's near as damn it. Okay. Well, the drawing requires that this end should be threaded M25 with a 1.5mm pitch for a depth of 6mm. So that means I've got to bore this out to 23.5mm for a depth of 6mm before we start cutting the thread. Well, that comes to 24.1, which is more than I wanted. This means we shall have a weak thread, but there you go. I always seem to overshoot despite allowing for all these things. With a 1.5mm pitch, it moves at quite a high speed, and as I haven't even got an undercutting at the end of this thread, I'm going to thread it by hand. Of course, most people make a handle for turning this, but I'm just going to turn it by hand. And so on until the thread is complete. Well, that seems to be alright. Well, it's just taken me half an hour to put the change gears back to their normal default setting after that metric thread cutting, because a tiny woodruff key fell out as I was taking the change gears off into this thing and got mixed up with all the swarf. So I had to take it all out, or some of it out, onto this newspaper and then scan it with a magnet to find this key. What a pain. If you can afford it, buy a lathe which has got proper change gears that you don't need to. You can just change the ratio with a lever rather than actually undoing gears and changing them over. It's a pain in the arse. Well, this design requires a 4mm stainless steel shaft which has got to be threaded with a metric thread for the first 30mm of its length. In my experience, when using dies to thread stainless steel, this is 316 stainless steel, it never works. The die goes on about 3 turns and then it jams, and there's no way of making further progress. Whatever cutting fluid you use or however much force you apply, you end up just twisting the rod or being unable to hold the workpiece. So I've found from experience that the best way of doing this is to skim off a few thou from the nominal thickness of the rod before you start, to just give the die some hope. It obviously leads to a slightly less satisfactory thread in the end, but it's the only way you can do it, or the only way I can do it at any rate. So I'm just going to try skimming 3 thou off this, very lightly, because obviously we don't want this thing to bend. And I'm also going to chamfer the end of this to give the die some hope of starting. And of course I'm going to do this manually. Hang on a moment. Let me just do this up tightly. Just put a mark on this so that I can see whether it's turning or not. Yeah, see, it's turning in the chuck, which it always does. Such a pain. I cannot chuck it any tighter. We're just making progress. Come on. There we go. Right. So that's all right, I trust. Well, that goes over there, but then it gets caught up. Oh, here we go. Right. So it's a pretty good fit. Overall. Good. It's just tight. It's just a little bit awkward passing those bearings over this shaft, so I'm just going to give it a bit of stainless steel polish. Oh, but not like that! What the sod? It's a bit better. Right, well, it moves a bit more freely now. Not that it's supposed to, I mean, it's supposed to be fixed to the inside of the bearings anyway, the inner race of the bearings, but I just thought that it was a bit stiff moving it through. The design calls for plastic spacers, cylindrical spacers between the bearings and between the top of the bearing and the wind vane. So I've got this 10mm diameter door ring here, and I'm just going to drill it out to 7mm. No, I'm not. I'm going to drill it out to 4mm, which is the diameter of the shaft, and then machine it down to 7mm on the OD. I'm using a fairly low speed because the other end of the rod is waving about in the breeze. Not that that will matter. I'll do this step by step, I think. Right, so that will slide over there. I've just got to turn down the OD and cut it to the appropriate length. So these 7.1mm here and 7.3 something there. So if I touch off here and go in 0.1mm and then run it, it should get it right. Right, that is touched off and it's on naught, which is the place I had it before. If I go back to here, go into naught +2, that should be it. And it should cut more off this end than that end. Stop it! Oh, this bloody shield getting in my way, you bastard! Still. there's a limit to the amount of perfectionism one can have in this country. It's going to have to do, because I can't be bothered with any more buggering around. I needed an HSS internal grooving tool, but I couldn't find one. So I was forced to buy this set of 3. These are 60 degree and 55 degree internal threading tools, which I didn't really want. And I got an internal grooving tool, and it was much too big, but I've ground it down. So that's quite convenient for cutting a groove inside a tube. Well, that's about as far as I can go without the wind vane or the Hall effect sensor, both of which, well, Ollie's got the Hall effect sensor and he may print the wind vane in due course. So I think I will put this in a jiffy bag and send it to Ollie and see what he thinks.